Are you struggling with piecewise functions? Today we're talking all about them. We're going to give you a definition. We're going to give you about 3 different examples, graph those examples, as well as check out some tricky inputs and see what they output. Let's get into it. Definition of a piecewise function is a function defined by multiple subfunctions, all right, each of which of those subfunctions applies to a different part of the domain. So, for example, in this one, the domain is going to look like this. All right, I've broken my domain up into these 3 different sections because it says it's when x is less than -1, so I need everything less than -1 for my x values. This part of the graph, x plus 2, is going to be there. For this middle part, that's where we're going to be between -1 and 2. -1 and 2, so we're going to have part of our graph, this part like that, inside there. And then lastly, on the right side, 1 minus x is going to be when x is greater than or equal to 2. So we're going to have these 3 different sections, and it's actually going to look like this. Okay, after graphing these, you can see that I graphed x plus 2, right? So it's going to have a positive slope. Usually we start up here at 2, but remember I'm restricted for when it's less than -1. This graph is going to be between -1 and 2, so that's right here. And it's when 2x plus 5, or y equals 2x plus 5. So I start at 5, I'd go up 2 over 1, but I also have to come back this way a little bit. It's between both those things. And then lastly, my last one, this could be also written instead of y equals 1 minus x as y equals -x plus 1. So I start up at 1, go down 1 over 1, down 1 over 1, and keep doing that. But remember, I can only start this when x is greater than or equal to 2. So here's my x, here's 2. So when it's greater than or equal to 2, it's going to be a closed dot since it's greater than or equal to, and going that way. All right, here we have the piecewise function g of x equals x plus 3, negative absolute value of x plus 5, and 1/3 x minus 1, all with these different restrictions on our domain. Okay, so if we want to graph this, I'm going to use black, red, and blue to help me graph on this graph down here. And let me just take this one piece at a time. So first off, I can only graph this one, x plus 3, when x is less than -2. So if this is my x-axis, and this is -2, I can only have, right, if I put my dotted line back here, I can only have that piece of the graph on the left side of that line. So if I do that, like I would graph it normally, x plus 3, this is just 1x plus 3. 3 is going to be my y-intercept. So 1, 2, 3 on the y-intercept would be right here. But instead of going up 1 and over 1, up 1 over 1, keep doing that forever, I want to be over here. Okay? So instead of going up and to the right, I need to go down and to the left. All right? If I go down to the left once, I get a little bit closer. If I go down and to the left another time, then I am at that line, which is where I want to be. I want to be less than -2. Now, it's not less or equal to, so at this point, I need an open dot. Right, I need an open dot there. And I'll erase my line to show you that we'll have everything less than that here in a second. Right, but then I need to keep going, right? So down 1 over 1, down 1 over 1, and I would do this until I can run off my graph. Your graph might be bigger than my graph, but this gives me a line, right, that looks like this. Again, my lines aren't the best. Hopefully your line's a little bit better. Use a straight edge or something. Okay? Now, my next one I'll do in red. This is going to be the absolute value of x, well, the negative absolute value of x plus 5. So remember, this is the absolute value function. It looks kind of like a V shape. The negative is going to flip it down, and then my plus 5 is going to move it from the origin up 5 spots. So I'm going to go up 5 spots, 1, 2, 3, 4, 5. And this one is including 0, so I can actually put a dot here. Put a dot here at 5. And then I'll be going down 1 and left 1 and down 1 and right 1 in both directions until I get to these restrictions. So let's see what that would look like. If I go down and to the left, then down and to the left, that'd be there and there. And then I'm at -2. At -2, I'm going to have a closed dot because this is less than or equal to. I'll draw the line here. And then if I go down and to the right, let's see here, down to the right 1, down to the right another 1, down to the right once more, then I'm at 3. 1, 2, 3 over on the x. That's where my restriction's stopping. This is just a less than, so this is going to get an open dot. I can connect it like that. Again, if you have real graph paper, your graphs will probably look a little bit better than mine. Okay, the last one we're going to do in blue, this is when x is restricted when it's greater than or equal to 3. So we're going to start with a closed dot at 3, and we're going to go to the right on forever, right? It doesn't stop. It's greater than all the rest of those. And this is the line y equals 1/3 x minus 1. Okay, so again, I'm probably going to start in the middle here, but I'll eventually erase those dots until I get to where I need to be. So at -1 is where I'm starting, down here. And it says 1/3, so that means up 1 over 3. 1, 2, 3. Well, good. Hey, right now, I'm already, if I start down here and go up 1 over 3, I'm already where I need to be, which is greater than or equal to 3. So at this point, I can actually put a closed dot. Okay, and then I'm just going to do it again until I run off my graph. So up 1 over 3. And if you had another spot on your graph, you go up 1 over 3 again, and you could connect all those dots, put an arrow at the end, so know that it's going on forever. All right, the next piecewise function we're going to look at is h of x is x squared if x is less than 0, or the square root of x if x is greater than or equal to 0. So in red, we're going to do this top one, x squared. And normally this is a parabola looking shape, right? But since it's less than 0, I can only do my domain when it's on the left side of 0, okay? So, for example, starting at 0, 0 squared, if I plug in 0, 0 squared is 0. But it's going to be an open dot there because that is not included. It's just going to be a less than, all right? Looks like we're going to get to that part maybe when we get to our next one. All right, what about -1? If I keep going to the left here, -1 squared, well, -1 squared is +1. So I'll put a dot there. This is going to be a little dot because I'll draw a graph. Right, -2 squared, if I put my next value in, is going to be 4. So -2, go up to 4 here. And then -3 is going to be up to 9. -3 squared is 9. Try to be pretty precise. And I get this parabola-looking shape, but it's only on the left side of 0. Okay, switching colors to blue. Now we're going to do the square root of x if x is greater than or equal to 0. So at 0, I can put a closed dot, and the square root of 0 is 0. So I'm going to actually put a closed dot right here inside of my open dot from my other one. All right, what's my next, I call it nice number that works. Does 1 work? Can I take the square root of 1? Yeah, square root of 1 is 1. So this is the point 1, 1. And then I'm going to skip until I get to 4 because the square root of 4 turns out pretty nice. It's 2. If I were to try to do like the square root of 2, I don't really want to graph, 1.4 or whatever it is. So this is at 4, the square root of 4 is 2. The next nice number is the square root of 9, which is up here at 3. Okay? In fact, let me do this a little bit better. This one should be a little higher. Okay, so if I graph these, connecting the dots, I can get that square root function like this. And so I have my quadratic function, but just the left side of it, as well as my square root function on the same graph because of the ability to do it with a piecewise function. All right, after graphing that, what I did is I put some tricky inputs on here, okay? So we're going to do f of -3, f of 0, 1, and 4. And if I look at maybe graphically f of -3, what that means is my x value or my input at -3, what's the output? And that's actually going to be at this point. So if you remember, 3 or -3 squared, right? That's what the function we use. -3 squared was 9. This is actually the point -3, 9. So you can say the output for f of -3 is just 9, the y value. At f of 0, it's going to be 0, okay? And even though that's an open dot for this one, it's a closed dot for the bottom blue function, okay? The square root of 0 is 0, so that is my output there. The next one at 1, well, again, I'm using the bottom function, and you can do it algebraically or graphically, either way. But if I plug in 1, the square root of 1 is 1, or graphically, you can see this is the point 1, 1 right there. Okay, so my output is 1. The last one, f of 4. Well, again, the square root of 4 is 2. Does that work on my graph? 1, 2, 3, 4. Yep, that's at the point 4, 2. So the output here is 2. Remember the piecewise function from the beginning of this video? All right, we had x plus 2, this 2x plus 5, this 1 minus x, and then the stipulation on the domain like this. Right? We can also find our inputs using it algebraically without a graph. So let's try that. What I mean by that is here we want f of -3. So I have to look at the rule that is telling me. That's over here in red. Where in the domain is x going to be -3? Well, it's going to be obviously where x is less than -1. So I have to use this rule, which means I'm using this piece of my piecewise function, and it's telling me if I plug in -3 for x here, that'd be like -3 plus 2. -3 plus 2, of course, is -1. All right, you can even go back to the beginning of this video, double check that on the graph it's at -1, and I promise it will be. Okay, what about f of -1? Where does that fall in line? Well, here's a -1 and here's a -1, but I can only use it where it's less than or equal to, okay? Because it's equal to -1 here. So at -1, I'm plugging it into this portion of my piecewise function, and at -1, that means I need to replace my x with -1. So I'm going to replace the x here, -1. 2 times -1 is -2. -2 plus 5, of course, is 3. All right, what about f of 0? F of 0 is between -1 and 2, so I'm going to use that same piece that I used on the last one. And again, I'm plugging in 0 for x. So 2 times 0 is 0. 0 plus 5 is just 5. So f of 0, in this case, would be 5. The last one, 2, well, again, it's kind of like what we had before, where here's a 2, here's a 2, but I'm going to use the part that's less, or that's greater than or equal to. So I have to use this part of my graph, which means I'm doing 1 minus x. Here the x is 2 that I'm plugging in, and 1 minus 2 is -1. All right, guys, hope this video on piecewise functions helped you out. If it did, please help me out by subscribing to this channel and leave a comment. All right, there's not a comment on my whole channel that I have not responded to. Let's see if we can flood this video with comments, and I'll be sure to respond to you. We'll see you in the next one.